Start, sir.
Okay. Good morning, students. Welcome to our webinar classes once again. So this is Kishan Reddy. Previous classes, we are discussed about ellipse. So ellipse in the various forms, we are having some one here. What is this? Recapitulation for that one. For this one, if the center not at the origin, if the center at the origin and the center not at the origin. So in this one, so first one is, second one is completed, and the third one is which is some dot is there. Then that is x minus h whole square by a square plus y minus k whole square by b square equal to 1, where a greater than b greater than 0, where a greater than b greater than 0. So this figure like this. So observe this one. This is x-axis, y-axis, center 0 comma 0, and so these are axis only. So this line, the ellipse lies on the this plane. So and the center changes to 0 comma 0 to h comma k. Okay, then the ellipse like this. So then these are directrix. So a dash, b dash, major axis, minor axis. So here in that one last class we discussed that is major axis is x-axis, major axis is x-axis, and y equal to k. Y we can take is a y equal to k. It's correct. So here this lies on the y equal to k and parallel to y-axis, x-axis. Y equal to k and which is parallel to x-axis. That's why taking y equal to k. Similarly here, so this is the major axis, and the minor axis x equal to h, x equal to h. This minor axis which is parallel to y-axis and which is x equal to h. These are the concept. So then length of the major axis is nothing but 2a, and the distance between a dash, that is nothing but 2a. Length of the minor axis is nothing but 2b, that is, and b dash, length of the b dash, and the center h comma k, and the foci is nothing but s, h plus or minus ae comma k. S is h plus or minus ae comma k. We are taking h plus ae comma k one side, right side of the y-axis, and the h minus ae comma k left side of the y-axis. So then next, so equation of the directrix equal to x equal to h plus or minus a by e, as we proved in the standard form, and eccentricity is nothing but the root of a square minus b square by a square. Okay, so then now the center not at 0 comma 0, and the condition is 0 comma 0 is less than a is less than b, 0 is less than a is less than b. So that is x minus h whole square by a square plus y minus k whole square by b square equal to 1. Then this figure like this. So then center x-axis, y-axis. So center transformed to h comma k from 0 comma 0. Then you will get like this, the ellipse like this. So this is a major axis, this is minor axis, and the a dash, b dash. So here b dash is the major axis and a dash is the minor axis. These are directrix. So then z dash. So then major axis is nothing but lies on the y-axis, that is x equal to h. Similarly, minor axis y equal to k. So I is the same one, previous one. So that is nothing but, so next one is nothing but length of the major axis 2b, length of the minor axis 2a, and center h comma k, and foci s hk plus or minus be. So we can change that one. So a in the previous that one h plus or minus ae, now this is lies on the y-axis, that's why we are taking h comma k plus or minus b. So and the equation of the directrix is nothing but y equal to k plus or minus b, and eccentricity is nothing but equal to under root of b square minus a square by b square, where b value is greater than a. Okay, so now we are going to ellipse class 3 now. So from in this one we can discuss so various types. So first one is ellipse and a point in the plane. of the ellipse. So what is saying that ellipse with respect to a point. So in a plane, so an ellipse divides xy plane into two disjoint regions. Similarly, in the previous parabola, we have discussed that one. So a point or a plane, in a plane, ellipse divides that plane as the plane into two disjoint regions. So one containing foci called the interior region. So one containing foci, that is called interior region. Okay, other region is called exterior of the exterior region. So I'm saying, repeating and once again, an ellipse divides the xy plane into two disjoint regions. One containing foci is called interior region other of the ellipse, and the other is called the exterior region here. Exterior. So this is exterior region. Exterior region. So this is exterior region of the ellipse. So let p x comma y be any point in the plane of the ellipse. So like this, p lies on the ellipse. If p lies on the ellipse, in the previous we discussed that one. So if a point lies on the ellipse parabola, and if a point lies in the parabola and the inside of the parabola, a point outside of the parabola, that's why you're same also inside on outside. So that is p lies on the ellipse. So if S11 equal to 0, that is the point lies on the given ellipse. If P lies inside the ellipse, that is S11 is less than 0. S11 is less than 0. If P lies outside of the ellipse, then S11 greater than 0, as in the figure. So first you have to know the values. So if n S11 means just we have the value x square by a square, x square by a square plus y square by b square equal to 1. So a point px comma y lies on this ellipse. Then if you are substitute the x comma y values in this equation, you will get S11 0. This is on the ellipse. If S11 less than 0, that is interior, so inside of the ellipse. And if S11 greater than 0, that value is exterior of the ellipse. Okay, next. So notations for this one, similarly here in the previous one, S11 we are taking that one. So I am taking here equation of the ellipse in the standard form is s equal to 0. So for that one we are taking, if a point px comma y lies on the ellipse, if a point px comma y lies on the ellipse, that one S1 I'm taking, that is S1 denoting with S1, that is x1 by a square plus y1 by b square minus 1. x1 by a square plus y1 by b square minus 1 at x1 comma y1. Similarly, if S2, I'm taking S2, that is nothing but x2 by a square plus y2 by b square minus 1. x2 by a square plus y2 by b square minus 1, where at x2 comma y2. If S12, just here we are substituting 2 points. In the previous one we are substituting only single points. Here at a time we are substituting 2 points, that is S12, that is x1 x2 by a square plus y1 y2 by b square minus 1. I'm repeating once again, S12 equal to x1 x2 by a square plus y1 y2 by b square minus 1, where the points x1 comma y1 and x2 comma y2 lies on the ellipse. And S11, this is x1 square plus x1 square by a square plus y1 square by b square minus 1 at p x1 comma y1. Okay, so these are the notations. So auxiliary circle. So the circle described on the major axis of an ellipse as the diameter is called auxiliary circle of the ellipse. What is saying that in the question? In this one, the circle described. So circle described on the major axis of an ellipse. Major axis of an ellipse diameter. So diameter is called auxiliary circle of the ellipse. The equation of the auxiliary circle of the ellipse, that is x square by a square plus y square by b square equal to 1, where a is greater than b, and this is nothing but is the auxiliary circle equation is x square by a square plus y square by x square plus a square equal to a square plus b square, x square plus y square equal to a square plus b square. This is the auxiliary circle equation. So which is saying that the circle described on the major axis of the ellipse. So the figure as follows. So see, this is x-axis, y center, y-axis ellipse, and a dash, b dash. So now the circle passing through the ends of the major axis, which is its diameter. So major axis is equal to diameter of the circle, that is called as the auxiliary circle of the respective ellipse. So this figure, I'm zooming this one. So observe this. So this value, so this blue line, the length of a dash, this is the diameter of the circle. That is the diameter of the circle. This circle passing through the end points of the major axis. So this is the main concept. So auxiliary circles. So eccentric angles and a parametric equation. Eccentric angle and a parametric equation. So let P be any point on the ellipse. Draw Pn perpendicular to the major axis and produce it to meet the auxiliary circle at Q. Then angle ACQ is called the eccentric angles. So I will show in the next slide. This is this figure. So let P be any point on the ellipse. I'm taking AP is lies on the ellipse and draw Pn perpendicular to the major axis. I'm drawing. So this is ellipse. So I'm drawing, this is major axis. So a point lies here, that is P. I'm drawing a perpendicular line. This is line. So then, and produce it meets circle. So auxiliary circle is there now. So that's one. So this is, and meet auxiliary circle at Q. This value is Q. Then ACQ angle. Here we are taking this value C. So ACQ, sorry, this value. So here ACQ is called the eccentric angle of the point P. Let us denote the angle as theta. Here taking as theta. So then P starts. One second. So if P starts from A and moves along the ellipse, if P starts from A and moves along the ellipse in the anti-clockwise direction, anti-clockwise reverse. So why anti-clockwise direction wise? So and comes once again at A, then theta will vary from 0 to 2 pi. What is saying that this is the round. So if you start with 0, we can count this one as anti-clockwise, and counting this is nothing. But again, if you reach this one, this is 0 or 2 comma pi. So 0 or 360 degrees is saying that. Okay. Next. So let the coordinates of P x comma y. We are taking P a point x comma y. Then x equal to a cos theta. X equal to a cos theta from the parametric. X equal to a cos theta, y equal to b sin theta. Similarly, we are taking from the triangle C and Q, cos theta equal to x by a. So that is nothing but we have to find the cos theta value from here. That value is x by a. Cos theta value, where CQ is the radius of the auxiliary circle. So then, so this is a figure from the above description. Observe this one. So this is a point P lies on the ellipse, that is x square by a square plus y square by b square equal to 1. So this is the perpendicular line. So this is the perpendicular line P to N, and extending to circle. Okay. So then QN, and this is value CQN is a triangle, or NCQ is also triangle. So observe the figure once again. So this one, this angle, as we are taking theta, this value is Cn, this value is PQ, and this Ca and P here. So this is P, I'm taking x comma y. P taking x comma y means Cn value is x and this Cn value is x. Okay, next we have the value of x. We have the value of x, that is x equal to x by a equal to cos theta. Okay, just x equal to a cos theta, then substitute the value. So this P lies on the ellipse, that's why we are taking x equal to a cos theta. Substitute in the equation, you will get a square of cos square theta by a square plus y square by b square equal to 1. Then y square by b square equal to 1 minus a square by a square cos square theta by a square cos square theta by a square. Then this, you will cancel this one. Then y square by b square equal to y square by b square equal to y square by b square equal to, this value will get y square by b square equal to sin square theta. That is nothing but 1 minus sin square theta. 1 minus cos square theta, that is nothing but sin square theta. So then y square equal to b square sin square theta, b square sin square theta. We are removing the squares from both sides, then you will get y equal to plus or minus b sin theta. So what is asking, we are taking x value as a cos theta. If we are taking x value as a cos theta, then y value will get b sin theta plus or minus b sin theta. So this is the parametric form. This is parametric form. Okay, next. So the coordinates of the P are of the form a cos theta, b sin theta, or a cos alpha, b sin alpha, where alpha is nothing but 2 pi minus theta. 2 pi minus theta, why are indicating this is nothing but cos of 180 minus theta. Cos of 360 minus theta is nothing but cos theta. Sin of 360 minus theta is nothing but sin theta. That's why we are taking alpha, that is 2 pi minus theta. Okay, so if a point a cos theta, b sin theta is called a point of theta, that is denoted by p of theta. This is the parametric form of the ellipse. This is the parametric form of the ellipse. And if you put x equal to cos theta, y equal to b sin theta in the equation, so the equation satisfies for all values of theta. So the equation satisfies the all values of theta. If you put x equal to a cos theta, y equal to b sin theta, then so hence the pair of equations x equal to a cos theta, y equal to b sin theta together yield the single equation x square by a square plus y square by b square equal to 1. So if you put the x value, y value, you'll get same value, same 1 equal to 1. So these are the known as the parametric equation of the ellipse. So theta is called the parameter. Okay, so just parametric form. Now, and eccentric angles. So the distance of a point on the ellipse from 3x square plus 3y square equal 6 from its center to is equal to 2 to find the eccentric angles. Just we have to find that one. So given ellipse is x square plus 3y square equal to 6. Just you have to transform into standard form, that is x square by 6 plus y square by 2 equal to 1. Then you will get a square equal to 6. Then you will a value as root 6 and b square equal to 2 and b value is root 2. So clearly in the question, what is saying that from the center to a point lies on the this ellipse equation, that is distance is 2. So that is, so we are taking any point on the ellipse p a cos theta, b sin theta, I'm taking that is root. This value is a value what will get a equal to root 6 and the b value is root 2. So just substitute there, that is value will get p value as the point, a point on the ellipse. So that's why I'm taking p a cos theta, b sin theta, that is root 6 cos theta or root 2 sin theta. Then so p value this one, and the center 0 comma 0, and the distance between those two is nothing but cp is equal to 2 in the question. So then distance between the 2 points, that is nothing but x2 minus x1 whole square plus y2 minus y1 whole square. This is under root, that is where we are under root of root cos theta minus 0 whole square plus root 2 sin theta minus 0 whole square equal to 2. Then this value will get root 6 under root of root 6 cos theta whole square plus root 2 sin theta whole square. So then you will get 6 cos square theta plus 2 sin square theta under root, which is equal to 2. Then you can do that once squaring on both sides. Then 6 cos square theta plus 2 sin square theta equal to 4. Just substitute the value as sin square theta is nothing but 1 minus cos square theta. Why? Because of identity formula of trigonometric, sin square theta plus cos square theta equal to 1. Then from that one we can find the value sin square theta equal to 1 minus cos square theta. Just substitute and simplify that one. That is 6 cos square theta plus 2 of 1 minus cos square theta equal to 4. 6 cos square theta plus 2 minus 2 cos square theta equal to 4. Then solve this one, you can get. So 6 minus 2. 6 minus 2 is nothing but 4 cos square theta, and that this 2 taking to right side, then you will get 4 minus 2 is 2. Then this value cos square theta, 4 cos square theta equal to 2. Then cos square theta equal to 1 by 2. Just take 2 right side, you will 2 by 4. Then you will get this value is 1 by 2. Then cos theta value is nothing but 1 by 2, where the value of 1 by 2 will get 45 degrees. So cos 45 degrees value is 1 by 2. So this is the eccentric angle. So this is the eccentric angle with respect to the first coordinate. Similarly, these are the eccentric angles for the given question. So given question, that is theta equal to pi by 4, 3 pi by 4, 5 pi by 4, 7 pi by 4. So this is the finding of eccentric angles. So once again I'm saying that. So question, just observe the question. The distance of a point on the ellipse x square plus 3y square equal 6 from its center is equal to 2. Find the eccentric angles. Just we have to find the eccentric angles. So we have to find the eccentric angles. That's why we have to take in a parametric form. Take in a parametric form. That is x square plus 3y square equals 6. Then a parametric form is nothing but p. I'm taking a cos theta, b sin theta. So just we have to find the a, b values and substitute there. And he given that from its center is equal to 2. Then we have to find the value of theta. So here Cp equal to 2. Just solve that one. You will get theta value as pi by 4. So then you can substitute that one as the coordinates. So you will get that values theta is nothing but pi by 4, 3 pi by 4, 5 pi by 4, and 7 pi by 4. Okay, next. So if theta 1, theta 2 are the eccentric angles, similar, so of the extremities of the focal chord other than the vertices of the ellipse x square by a square plus y square by b square equal 1, where a is greater than b and its e is its eccentricity, then show that these two, first one is 1. E cos of theta 1 plus theta 2 by 2 equal to cos of theta 2 plus theta 2, theta 1 minus theta 2 by 2, and the second one is e plus 1 by e minus 1 equal to cot of theta 1 by 2, cot of theta 2 by 2. This is the question. So here what is saying that here two angles is there, that is theta 1, theta 2, theta 1, theta 2. So then these two are eccentric angles and the extremities of a focal chord. Focal chord means a chord passing through the focus other than the vertices. So then the ellipse of this one is nothing but a is greater than b, a is greater than b, and e is the eccentricity. Then show that this one. So first we have to know the value of, we have to remind the values, remind the formulas of sine of a minus b, cos of a minus b, sine of a plus b, cos of a plus b, sine 2a, cos 2a formulas. So as per the sine 2a is nothing but 2 sine a cos a. So cos 2a is nothing but already here. So that is 2 cos square theta minus 1, cos square a minus 1, and the sine of a plus b, sine a cos b plus cos a sine b. Cos of a plus b is nothing but cos a cos b minus sine a sine b. So you have to substitute that formulas. You have to remind that one. So that is, you have to, first we have to prove this one. So for this one solution, so I'm taking this one like this figure, I'm taking like this one. So that is ellipse, and which is a focal chord, that is PSQ. So I'm saying that PSQ lies on the same line. That's why these PSQ are collinear points. These PSQ are collinear points. So for that one, and first P of theta 1, P of theta 2. So what is the P of theta? P of theta is nothing but indicating the parametric equation. So parametric form. So parametric form is nothing but P is taking a cos theta, comma b sin theta. I'm taking as P of theta. Here in the question, he given that he mentioned theta 1 and theta 2. So that I'm taking P of theta 1, P of theta 2. That is B2 extremities of the focal chord. That is P of theta 1 and Q of theta 2. I'm taking here. So of a focal chord, of the ellipse, this is Q. So as for the figure, so of the ellipse, then so x square by a square plus y square by b square equal to 1, where a is greater than b. I'm taking here b p value as a cos theta 1, b sin theta 1, q value as a cos theta 2, b sin theta 2. So here these values does not equal to theta 2 equal to pi, and theta 1 is not equal to 0, and the focus is nothing but we are taking a comma 0 as the focus. So first to assume this one, these are theta 1, these are theta 2. So that is p and q, and psq are collinear. So psq are collinear means, just how can we prove that the dead value equal to 0 or the slope values? We can find the slope values. So then for that one, I'm taking, so but PQ is a focal gun, and so PQ are collinear. Similarly, okay. No, next we have to do as per the slope of PS equal slope of SQ is nothing but the collinearity property. Then what is the slope? That is y1 minus y2 by x1 minus x2. Otherwise y2 minus y1 by x2 minus x1. Similarly, I'm substituting the x1, y1, x2, y2 values in the slope formula. So then I will get b sin theta minus 0 and a cos theta, b sin theta minus 0 by a cos theta 1 minus ae equal to b sin theta 2 minus 0 by a cos theta 2 minus ae. So just I'm repeating, b sin theta 1 minus 0 by a cos theta 1 minus ae equal to b sin theta 2 minus 0 by a cos theta 2 minus ae. Then just solve, just remove the zero terms there. B sin theta 1 by a, I'm taking from these two, I'm taking a common. Similarly here also, then I will get b sin theta 1 by a of cos theta 1 minus e equal to b sin theta 2 by a of cos theta 2 minus e. Just so you have to do the cross multiplication. So then you will get a of cos theta 2 minus e into b sin theta 1 equal to b sin theta 2 equal to a of cos theta 1 minus e. Just multiply that one, you will get values ab cos theta 2 sin theta 1 minus ab e sin theta 1 equal to ab sin theta 2 cos theta 1 minus ab e sin theta 2. So I'm repeating once again, ab cos theta 2 sin theta 1 minus ab e sin theta 1, which is equals to ab sin theta 2 cos theta 1 minus ab e sin theta 2. Just you have to take these values to left side and these values take to right side. So whatever it may be, you will get. So then as your wish, that is, so I'm taking, so like this one. So then ab cos theta 1 sin theta 2 as here, and that this value I'm taking to left side, I will get minus this value is plus, taking to left side it will be going to negative, that is minus ab sin theta 2 cos theta 1. I'm taking this negative value to right side, that will get that value as positive, that is ab e sin theta 1 minus here negative value as similarly I'm writing, that is minus ab e sin theta 2. So from this one, these two have to here observe this one, AB is here, AB is here, and AB is here, and AB is here. Just you have to cancel this one. Then you will get take the common, then cancel it one. So before that, AB is taking common, AB is taking common. So this value is sin theta 1 cos theta 2 minus cos theta 1 sin theta 2. So then here sin theta 1 minus sin theta 2. So here AB gets cancelled. You will get value sin theta 1 cos theta 2 minus cos theta 1 sin theta 2 equal to E of sin theta 1 minus sin theta 2. So next, then this value I'm taking to this value sin of A minus B formula. So sin of A minus B formula, that is sin theta 1 minus theta 2. That is sin theta 1 minus sin theta 2. Sin theta 1 minus theta 2. That is sin A cos B minus cos A sin B formula, as per the sin of A minus B form. So, and this value is nothing but similarly I'm writing E of sin theta 1 minus sin theta 2. Then I will get this one. From this one, we can, so this is the formulas. So now we can use this one. So this value, so here this value I'm taking in the previous one. So this is sin theta of minus sin of theta 1 minus theta 2. I'm taking this one as per the compound angles formulas. As per the compound angle formulas, sin 2 theta equal to, we can take 2 sin A cos A. Similarly, sin theta value I'm writing sin theta value 2 sin theta by 2 cos theta by 2. I'm writing 2 sin theta by 2 and cos theta by 2. So this value is nothing but sine theta. Okay, from the compound angles, multiple and submultiple angles. So that is the most. So this is value sine 2 theta equal to, we can write 2 sine theta cos theta. I am writing sine theta value as 2 sine theta by 2 cos theta by 2. Okay, so then, so this values, so here I'm writing here 2 sine theta by 2 cos theta by 2, and this value is sine of a minus b formula. So then just substitute the values, then you will get sine a minus sine b value. So then you will get this value sine of theta 1 minus theta 2 by 2 cos of theta 1 minus theta 2 by 2. Then this e of previously, that is sine a minus sine b formula, or sine c minus sine d. Generally we note that is sine c minus sine d. I'm taking the sine a minus sine b. Here we got that 2 cos of a plus b by 2 of sine of a minus b by 2. Then here theta 1 plus theta 2 by 2 and theta 1 minus theta 2 by 2. I'm repeating, this is 2 sine of theta 1 minus theta 2 by 2 cos of theta 1 minus theta 2 by 2 equal to e of e times of 2 cos of theta 1 plus theta 2 by 2 sine of theta 1 minus theta 2 by 2. Here clearly observe that these value will get cancelled, and so these two value also gets cancelled. Whether because of these are both are equal. So then we can get cos of theta 1 minus theta 2 by 2 equal to e of cos of theta 1 plus theta 2 by 2. Okay, so this value cos of theta 1 minus theta 2 by 2 equal to e of cos of theta 1 plus theta 2 by 2. So just we have to find the values, that is e equal to cos of theta 1 minus theta 2 by 2 by cos of theta 1 plus theta 2 by 2. This is the enough to prove. So for the first question, so now, so from 1 we know the values of this one, we know the value of this one. So what is saying in the e value as in the from 1 to cos of theta 1 plus theta 2 by 2. Here we can do you know what is the compound endo dividendo? So in the first year trigonometry problems we did that one, compound endo dividendo. So first, before that, by doing the compound endo dividendo, we get the solution of this one. So what is the compound endo dividendo? That is a by b writing as a plus b by a minus b. This is the compound endo dividendo form. So just we are writing a by b, writing as a plus b by a minus b. This is the compound endo dividendo. Then so then I'm writing here e value and the b value. I'm taking this a by b, so I can write e plus 1 by e minus 1, e plus 1 by e minus 1. So e plus 1 by e minus 1. So e plus 1 by e minus 1 cos of here a by b, here a by b, which means a plus b by a minus b, a plus b by a minus b. Similarly, I'm just doing compound endo dividendo for the first one. So then I will get e plus 1 by e minus 1 equal to cos of theta 1 minus theta 2 by 2 plus cos of theta 1 plus theta 2 by 2 by cos of theta 1 minus theta 2 by 2 minus cos of theta 1 plus theta 2 by 2. So this is the formulas, cos c plus cos d, or cos c minus cos d, or cos c minus cos a minus b. Here I'm writing this value is c, this value is d. So this value cos c plus cos d, cos c minus cos d. So just to substitute the values, what is the cos c plus cos d? Just to remind this one. So 2 cos c plus d by 2 into cos of c minus d by 2, which is formula for the cos of c plus cos d, which is cos c minus cos d, nothing but 2 sin c plus d by 2 into sin d minus c by 2, otherwise minus 2 sin c plus d by 2 into sin of c minus d by 2. That is due to here minus you will get whether because of c minus d. If you write, you will get minus here. If you don't write the minus, then you will get this one formula. So here in the numerator term of right side value cos c plus cos d, and the denominator value cos c minus cos d. Then just apply that one, e plus 1 by e minus 1. I'm applying the cos c plus cos d, then I will get 2 cos c plus d by 2 into cos c minus d by 2, and that cos c minus cos d by, that is nothing but 2 sin c plus d by 2 into sin d minus c by 2. So just apply that one, 2 cos of theta 1 minus theta 2 by 2 plus theta 1 plus theta 2 by 2 whole by 2, then cos of theta 1 minus theta 2 by 2 minus theta 1 plus theta 2 by 2 by whole by 2. Just simplify this one. this 2 taking LCM and multiply with this one, you will get 4. Then this theta 1 minus theta 2, theta 1 plus theta 2, then you will get this will be cancelled, then you will get 2 theta 1 by 4. Similarly, I here also this value is theta 1 and theta 1 gets cancelled, you will get minus 2 theta 1 by 2. Then cos of minus theta is nothing but cos theta. Cos of minus theta is nothing but cos theta, and sine of minus theta is equal to minus sine theta. You have to know that one. So then this one, similarly in the denominator, 2 sine c plus d by 2 of sine c minus d minus c by 2. So then just apply that one, you will get similarly. Then theta 2, this is minus 2, this is plus 2, you will get cancelled, and 2 theta 1 by 4, and this will also, this theta 1 minus theta 1 gets cancelled, then sine of minus theta by 2. So then, so you will get this value. Okay, then E value as E plus 1 by E plus 2. So this is cos value. So this 2 gets cancelled. This value cos by sine is nothing but cot, and cos by sine is nothing but cot. So this is theta 1 in the form of theta 1. This is in the form of theta 2. You will get this answer. Okay. Just you have to do from the one given, one proved one, and also apply the formulas. Okay. Next. So if that is the most important problem, and you have to take as an assignment this formula, this sum as assignment. So if the fourth one, next question, C is the center, A dash and B dash are the major axis, which means this is major axis, this is minor axis of the ellipse x square by a square plus y square by b square equal to 1, which is nothing but a should be greater than 0. If Pn is the ordinate of a point P on the ellipse, then show that Pn whole square by a dash n an equal to bc whole square by ca whole square. Just we have to prove that this one. So from the figure I'm taking, this is the figure for the given question. So that is, so a dash is the major axis, which means a dash, and the b dash is the minor axis. I'm taking b dash, and the a point lies on the parabola, ellipse, and a pb is the ordinate. Then I'm taking pn. So then p of theta is nothing but a cos theta, b sin theta from the parametric form. Be a point on the ellipse x is equal to x square by a square plus y square by b square equal to 1. Then pn value I'm taking, this is this value. So here this is the length, this is the length, this is length of x, this is the length of y. That's why I'm taking cn as a cos theta, if cb as b sin theta. So and I know the values. This length is ca length is equal to ca dash length. I'm taking ca length equal to ca dash length, and cb length equal to cb dash length. cb length equal to cb dash length. So observe this one. So this is, I'm taking p of theta a cos theta b sin theta, be a point on the ellipse, that is s equal to x square by a square plus y square by b square equal to 1, and the pn value is b sin theta cn, which is nothing but a cos theta, and ca equal to ca dash equal to a, cb equal to cb dash equal to b. Then so this is ca value a, so this is cb value b. So then LHS before that one, you have to observe this one, the figure. So this is the green line CA, and this line is CB. The length of this line is B. This length of this one value is A, and PN value. Next, from LHS in the question, what is asking that Pn whole square by a dash n into an. That is, we have to prove that BC whole square by CA whole square. I'm taking the left hand side value Pn whole square by a dash n into an. So here in the value, this I am taking a, this value is a dash, this is C a dash, this is a. So from this one a dash n is here. So a dash n, so a dash n writing, I am this value plus this value, which means a dash c plus cn I'm writing here. So and the an value, this an value I'm writing an minus of this one, that is cn. I'm writing here ca minus cn. Clearly observe this one, ca dash n, nothing but this length is nothing but this length plus this length, and this length I want to this length, I'm taking total this length minus this length. Okay, then I will get this one else. So that is pn whole square by ca dash plus cn of ca minus cn. Then I will get, so what is the pn value? Pn value in the previous, so in the previous slide we take that one, pn value is b sin theta whole b sin theta, and cn value is a cos theta. So from that one I'm taking and I'm writing the substituting the all the values, and the ca value, ca and ca dash value is a, I'm substituting the pn value as b sin theta whole square by a plus a cos theta of a minus a cos theta. So just to substitute the expand that one, this value is a plus this value is b sin theta whole square by, then that value can be written as b square sin square theta by a plus a cos theta, a minus a sin cos theta. Then just simplify that one, b square sin square theta by a square of 1 minus cos square theta. I'm writing this one. So 1 plus cos theta into 1 minus cos theta, that is nothing but a plus b into a minus b, that is nothing but a minus b whole square. I'm writing similarly there. Then I will get b square sin square theta by a square of 1 minus cos square theta, then b square by b square sin square theta by a square of this can be written as sin square theta from the sin square theta plus cos square theta equal to 1, b square by b square sin square theta by a square sin square theta. That's, you will get cancel this one, so you will get b square by a square. So b square here, b square is nothing but I'm taking bc square. So in the question, that is nothing but major axis is nothing but, if I'm taking a and this value is a dash, so this is b and the b dash. So then, so the length is nothing but b, and also I'm taking this length is nothing but a. So here the center, so cb length is nothing but cb is nothing but bc. So I'm taking this value as b, and this value as ca, so which is nothing but a, I'm taking as ca. Then I will get the right side value bc whole square by ca whole square. This is the solving for the given question. Okay, I hope all the students getting this one. Okay, next. So length of the semi major axis is CA or CA dash equal to A. Length of the semi minor axis is CB or CB dash equal to B. So this is the class for today. Thank you one and all. Thank you, madam. Thank you, sir.
Thank you, sir.
Hello. Okay, ma'am.
Thank you, sir.
Thank you, sir.
Okay, ma'am. Thank you. Okay, right.